All right, welcome back, everyone. Um, we left off last time talking about just simple ionic compounds. Those are simple compounds that have a metal and a non-metal, and just a simple metal, something from group 1 or group 2 or group 13, so none of the ones in the middle. For this lesson, you're going to need your notes package. We're going to be starting on the note that's marked multivalent metals. It'll look a little bit different from this. I changed it around just a touch in order to make it a little bit easier to use here for the presentation. But as usual, if any time during the lesson you need to stop, you want to rewind, please go ahead and do that if you want to look over something twice. But you are going to need this part of the notes package in front of you. And then it would also be helpful if you had these two periodic tables from your notes package. So there's this one, which is somewhere near the beginning of your package. It's called the periodic table of ions. And then there should be a second one there, which is, this is your test periodic table. It says do not write on this table in big bold letters at the bottom. And this one is designed for you to use for all of your quizzes and tests whenever we will be doing that. So this is a good one to use when you're doing practice, because this is what will be available to you during your evaluations. So you'll need to have, probably it'd be a good idea to take these out of your package and then have it in front of you while we're going through this together. Okay, so the purpose of this lesson here is to learn a new set of rules specifically for multivalent ionic compounds. So the multivalent ionic compounds are the ones in the middle. Okay, they're the ones that have more than one potential charge. So for the ones in group 1 and group 2, we've done these ones already. For example, like barium arsenide. Barium arsenide is Ba. Barium's in group 2. So everything in group 2 is going to have a charge of 2 plus. And arsenic is in group 15. So it's going to have a charge of 3 minus. And you use your crisscross rule. And then this is going to end up having a formula of just Ba3 As2. Another example would be aluminum bromide. Aluminum has a charge of 3 plus. Bromine has a charge of 1 minus. You do your crisscross rule, and you're going to end up with a formula for aluminum bromide of AlBr3. Yeah, that's just straightforward. Those are just simple binary ionic compounds. What we're going to talk about today is when you have, like I said, one of the metals from the middle. So those are called transition metals. They are the metals that are at this part of the periodic table in here, not including aluminum. So if you look at these ones all have more than one potential charge. Not all of them have this. So if you look at your ion periodic table, there are some transition metals in the center here that only have one charge, like molybdenum, for example, or silver or cadmium. So those ones are also transition metals, but they're not multivalent. Multi meaning multiple or many, and then valent for charges. Okay, so potential valent states that they can be in. These can accept more than one, they give away more than one number of electrons in order to become stable. So for example, iron can give away 2 electrons to become stable, and then it's going to become Fe2 plus, or iron can give away 3 electrons to become stable, then it's going to become Fe3 plus. So those two ion forms of iron have different names. So normally, like sodium, for example, you would just call that a sodium ion. But if it's iron 2 plus, specifically because it can be more than one charge, you have to give it a specific name. So this one is called iron 2. And when you write the names of these, you're going to write it in brackets with a Roman numeral. So iron 2 looks like that. And then iron can also give away 3 electrons to become stable. So it could also become iron 3. So then you're going to write the name iron, and then Roman numerals in brackets. Okay, so that's iron 3. So all of these different ones in the center here, these different transition metals, can potentially have different names. So you can have, for example, chromium 2 or chromium 3, or manganese 2 or manganese 4, or iron 2 or iron 3, or cobalt 2 or cobalt 3. So there's a whole bunch of different ones in the center here. It would be a good idea for you to have a general sense of which ones these are that can become multivalent, because later on, if you can identify them quickly, it'll help you write the names and formulas for these. As it stands right now, like while you're doing these practice problems, like look it up. So just check on your table, and usually if you're checking your table as you go, and then you do like a bunch of practice as we do in the course, it's just going to come natural to you that you'll be like, oh, gold is always multivalent, or iron is always multivalent. So like you'll get a feel for it the more you practice it. Okay. By the way, on here, some of these only have one of their valence states shown. For example, tungsten, but this is just the most common one. So I didn't write the other tungsten states. Tungsten can do other ones as well, but so technically only one is shown here. But all the ones that have charges shown on here do actually have more than one. Another example here would be silver here. So silver is 1+, but it can actually be more than just 1+, and same thing with cadmium. So and zinc. So there's only one written here, but they are technically multivalent. Okay, so what do you do with that then? Well, when you write it, you got to indicate when you're writing the formula now which ion it is, and the ion that it is dictates how many you need of each of the different components in order to make the compound. So, for example, iron 2 is going to be iron 2+, and then the nonmetal part here is chlorine, 1-. You can read that off the table. And so this is going to end up being, we're going to need 2 chlorines for every 1 iron. So when you do the crisscross, you're going to end up with FeCl2. So that's iron 2 chloride. And when you say the name, you just say the 2. So it would just be called iron 2 chloride. By the way, this might be a good time to actually write out what the different Roman numerals are. I don't know if you guys know your Roman numerals. I don't know if you've had an opportunity to learn that in the past, but let me just write them down so you can see what they look like. So we've got 1, 2, 3, 4, 5, 6, 7. I could keep going here. I don't think I've ever seen one past 7, so why don't we just leave it there? And then let me write down beside what all these are. So this is 1, 2, 3, 4, 5, 6, 7. Okay, so that's what you're going to use to indicate which of the particular charges the ion will have in that particular situation. And these compounds have different properties. So iron 2 chloride, for example, is like, it looks different than iron 3 chloride, which can also form. Did I write iron 2 chloride here twice? That's by accident. Okay, so this second one here is supposed to say iron 3 chloride. Sorry about that. That should be iron 3 chloride. So iron 3 chloride is going to be Fe3+ and Cl-. And then when you do the crisscross rule, here you're going to end up with FeCl3. So that's iron 3 chloride. And iron 3 chloride doesn't look like iron 2 chloride. So they're different compounds with different properties. And they form under different conditions. So different pressures, different amounts of energy are going to form these two different iron compounds with chlorine. Okay, let me do one more example together with you here. Copper 1 oxide. So copper 1 oxide is copper, and then 1+. So I'm just going to put a plus up there. And then oxide you can look it up in your table. It's 2-. And so when you do the crisscross rule here, copper 1 oxide is Cu2O. Copper 1 oxide looks like that. Okay, so when you're going from the formula to the name, it's pretty straightforward, except you just need to make sure that you write down the correct charge for that particular ion of a given thing. So if it's copper 1, you need to make sure it's 1 plus. If it's copper 2, you make sure it's 2 plus or whatever. So going from the name to the formula here is pretty straightforward. It's really not that much more difficult than just writing out the ions and doing the crisscross rule like you did before. Okay, but it adds like an extra step. So you gotta make sure that you write the correct charge for each. All right, so I'm gonna do a few more of these here. So we'll go through the steps together. So the first thing is that you're gonna write the symbols and then write the charges. Okay, so you're gonna write the symbols. Symbol for iron is Fe, and the symbol for sulfide is S, or the symbol for sulfur is S. This is iron 3, so this is 3 plus, and it's sulfide, which is, let's look this up on the table real quick. Sulfur is in the same group as oxygen, group 16. That's going to be 2 minus. Okay, and then the last part here is that you're going to do the cross and potentially reduce. So we're going to do crisscross rule. And this is going to become Fe2S3. Okay, so that's iron 3 sulfide. All right, let's try two more here, and then we're going to go in the opposite direction. So this is going from, you have the name, and you're writing the formula, and then afterwards we're going to talk about what happens if you have the formula, and you have to work backwards and write the name. So, okay, copper 2 chloride. So step 1, you got to write the symbols. Okay, copper, chlorine. Then you're going to write the charges. So copper, the charge is right here, 2. And chlorine, you read off the table. It's in group 17, so it's going to have 1 minus charge. You do your crisscross rule, and then you're going to write the final formula. So this is CuCl2. So that is copper 2 chloride. Okay, last one. Lead 4 oxide. Step 1, write the symbols. So the symbol for lead is Pb. Hopefully you guys have been looking over the table and you're starting to learn the ones that you were supposed to memorize at the beginning. Lead is one that always trips people up. So lead is Pb, and oxygen oxide is 4, or is O rather. The charge here on the lead is 4. So this is going to be 4 plus, and oxygen is in group 16, 2 minus. We're going to do our crisscross rule. But one thing you should notice here is that both of these numbers here are divisible by 2. So if both numbers are divisible by 2, it's a ratio, so you can reduce. So it would be, if you didn't do the reduction, it would be Pb2O4, but you are going to reduce, so you can divide both of these by 2, and so this is going to end up being PbO2. Okay, so I'm going to give you an opportunity to practice this in a second here, but first I want to show you how to go in the opposite direction. So this part is fairly straightforward. You write out the ions and you do the crisscross rule, just like you did previous. Going in the reverse direction is a little bit more tricky because you have to figure out which ion you are currently using. Okay, so again, this was easy to do before. For example, you wanted to go from the formula NaCl and you wanted to name it. Well, you just give it its name. You name this ion, and this ion sodium, and then you name the other ion, which is chloride, and then you just put it together, sodium chloride. So that's pretty straightforward, just name the ions. The difference here is that now the metal ion on this side could have more than one name. So it could potentially be like copper 2 chloride, or it could be copper 4 chloride, and you got to figure out which one it's going to be. So at the beginning, when you see a compound, you've got to check, is this metal that I'm looking at a multivalent metal? And that's where it comes in handy to know which ones are multivalent metals. You're not going to know at the beginning, and that's fine. But eventually you'll sort of get a feel for which ones are multivalent as you go. So sodium is not multivalent, so we can just name it. But if it is multivalent, you have to include that Roman numeral to indicate which one it is. Okay, so let's talk about some multivalent examples here. All right, so cobalt. You're looking at this ionic compound and you see cobalt. You should say, oh, cobalt, that sounds like one of those multivalent ones. And if we go back up to our table, you'll see cobalt is right here. Okay, so cobalt is multivalent. So now we know we can't just call this cobalt something. It's going to be cobalt 2 or cobalt 3. So in order to figure out which one it is, it could be 2 or 3, we got to do what's called the reverse crisscross. So in order to get this formula, if we were going the other direction, we would have crisscrossed the numbers down. Here we're going to go backwards. So I'm going to take these numbers and I'm going to cross them back up and have them represent charges again at the top. So let's say it's cobalt 3 plus, that's right, cobalt 3 plus and oxygen 2 minus. So the cobalt could be anything. We don't know what the charge is going to be on this one, but we do know what the charge should be on this one, so that the nonmetals are not multivalent. If you look over at the table here, you'll see that none of the nonmetals here are multivalent, with a couple exceptions. These ones down here are actually metalloids, so we're not going to worry about those, and you're not going to see those. But the nonmetals that you are going to see, these guys over here, are not multivalent. Okay, so we know what the charge on oxygen should be. So oxygen is right here. So we know that the charge on this, because it's in group 16, should be 2 minus, right? We know it should be 2 minus. So what we're going to do here is check, is this 2 minus? Okay, so we're doing a check to see, is this 2 minus? And if the answer is yes, then what that means is that the charge that you have here for cobalt is also correct. So if that is correct, then that means that the other one is correct. So then that means that one's good. So if we know that that charge is correct for cobalt, then we know what it's called. It's called cobalt 3. So then we're going to name it cobalt 3 oxide. And we got to use the Roman numerals here for 3. Cobalt 3 oxide. If that number there is not correct, then we got to figure out what you have to do to that number in order to make it correct. So maybe you have to multiply it by 2, maybe you have to multiply it by 3, and whatever you do to that side, you're also going to do to the other side. Okay, so I'm going to show you some examples of what that looks like, but if it is in fact correct, if you do the reverse crossover and put the charges back up there, and this number for the nonmetal is the correct number, well, then you know that the number for the charge that you got for the metal is also correct. So this is going to be cobalt 3 oxide. So let's do an example where it isn't correct. Okay, let's have a look at our next one here. So this one right here is FeO. Okay, so first of all, let's do the reverse crisscross. So we looked at this element right here, and you think about it and you say, oh, that element is multivalent. So I can't just call this iron oxide. If I called it iron oxide, we wouldn't know which iron it was, and we have to know that. So we're going to do the reverse crisscross. So I'm going to take my number from down here, which is a 1, and my number from down here, which is also a 1. If there's no subscript shown, that's a 1. So now we've got a 1 minus up here and a 1 plus up here. And again, we look at the non-metal charge. Is that charge on oxygen the correct one? So again, we already used oxygen here, so hopefully that's fairly obvious. Oxygen is supposed to be minus 2. So it's not minus 2, it's minus 1. So we have to fix it. So what did we have to do to get this to minus 2? This is supposed to be minus 2. We've got to multiply it by something in order to get it to minus 2. So what could we multiply this by in order to get it to minus 2? 2. So we need to multiply this one by 2. If I'm, that's really hard to see. Let me try that again. Use a little bit. There we go. Multiply it by 2. So if we multiply the first one by 2, that's just like doing the reducing when we're going in the opposite direction when we're writing our formula. So when you reduce it, you always divide both numbers by the same number. So when we go the opposite direction, we have to multiply both numbers by the same number, which means we have to multiply the charge for iron by 2 as well. So now we're going to have a total here on this side, a total over here of 2 plus. 2 times 1 is 2. So this is going to end up being a 2 plus charge over here. So then we know that the correct charge for iron is going to be 2 plus. So this is iron 2 oxide. All right, hopefully this hasn't been too confusing so far. This is the point where people start getting a little bit confused. So we're going to do some more examples together, don't worry. And I should also mention at this point that if by the time we're done going through this, if you're like, uh-oh, this is a problem, we still have that question period on Friday. Please stop by. I can do some examples just like this and we can talk about it. It might make it a little bit easier to clear stuff up. Okay. So let me do some examples here with the reverse crisscross. So I've got this here, WO3, that's tungsten and oxygen, okay? And we're going to do the reverse crisscross. So I'm going to write it out again. That's W and O and 3, and I'm going to reverse crisscross. So I'm going to bring this charge up here, and I'm going to bring this charge up here, or I'm going to bring the number up and make it into a charge. So this is going to become 3 plus, and this is going to become 1 minus, okay, because I brought the 1 up. Okay, so then you always look at the non-metals charge, okay, so the non-metals charge is over here. It'll be the one on the right always. The non-metals charge here, you have to check, is it correct? So is -1 the correct charge for oxygen? Have a look at your periodic table if you're not sure. No, this is supposed to be -2. So in order to turn this into -2, we would have to multiply this by 2, okay? Multiplying this by 2 would make it -2, the correct number. If you multiply this side by -2, rather, you have to multiply the other side by 2 as well. So if you multiply the other side by 2, you end up with 6 on this side. 2 times 3 is 6. So that is going to be the correct charge for tungsten. So then when you write the name, we're going to call this tungsten 6 oxide. So 6, remember, is, do my Roman numerals correctly here, Vi. Okay, so this is tungsten 6 oxide. All right, I'm going to do a few more. PBS, okay? So PB and S, they both have a subscript of 1. Okay, so I'm going to do the reverse crisscross, bring up a 1, bring up a 1. I'll give this a charge of 1 minus and 1 plus. And then you look at, again, the charge on the non-metal. Okay, the charge on the non-metal for sulfur, is that correct? So if you need to, you can go all the way back up to your periodic table, and you can look at sulfur, say, oh, it's in the same as oxygen here, group 16, so that's going to be a charge of -2. Well, that's not correct. That's not a -2. So in order to get -2, I got to multiply it by 2, and which means I need to multiply the other side by 2, which is going to give me a total, oops, multiplied by 2, which is going to give me a total on the left side for the metal of 2. Okay, 2 times 1 is 2. So this is lead 2 sulfide. All right, I'm going to do these next ones, these next two a little bit faster, and then I'm going to give you an opportunity to try some practice. I'll do one practice problem for each of these, and then let you give it a shot. Once you've done that, I'm going to come back. I'm going to pause, and then I'm going to give you an opportunity to come back. I'm going to take them up really quickly, and so you can see what the take up looks like and double check your answers. Okay, SnCl4. Sn is tin. So this is tin and chlorine. I'm going to bring up a 1. I'm going to bring up a 4. So we're going to end up with a 4 plus charge and a 1 minus charge. So you look at this one and then you have to check, is that the correct charge for chlorine? If the answer is yes, that's the correct charge for chlorine, then this is, which it is, a -1 is the correct charge for chlorine. So this is going to become tin 4 chloride. Yeah, wait, that's 4. Yeah. Tin 4. All right, one more. And again, before you start to actually do the reverse crisscross and do all this, you have to check. I mean, I'm doing the check in my head here, but you have to check, is that metal multivalent? If it's not, and so Zn, or Zr rather, let's have a look. Where are you, Zr? Where are you, zirconium? So zirconium is over here. It's a transition metal. Whoop. Let's have a look. Is it multivalent? No. It doesn't have more than one possible charge. So this is an example of one where you don't write the Roman numeral. Zirconium only has one possible charge. So when you write this one, I guess it's kind of a trick question to throw in there. You don't need to do the reverse crisscross. Tin is multivalent. It can have more than one charge. Lead is multivalent. It can have more than one charge. You got to do the reverse crisscross. Tungsten, multivalent. It can have more than one charge. But zircon, no. Zirconium, nope. So you would just call this zirconium oxide. Ooh. There we go. Yeah, so no Roman numeral needed because that metal, I may as well write this right on my note here. So there's no Roman numeral because this is not multivalent. So that's what it mentions again here at the bottom. So you only use the Roman numerals if the metal is multivalent. If it's not multivalent, you don't use them. Okay, this is where the challenge is because this is a mixture. Some of these that you see over here are going to be just simple binary ones, like, for example, aluminum nitride. That's just a simple binary one because the metal there is not multivalent. But some of them are going to be multivalent. Actually, hold on. Are any of these multivalent? Yes. So some of these are. Yeah, obviously we've got the Roman numerals here. So for example, this is copper 1, iron 3. So those are the multivalent ones. When you're trying these ones at the bottom, you got to check, unless you know which ones are transition metals and are multivalent. So for example, we got some over here like magnesium. Magnesium is just a regular metal that isn't multivalent. And we've also got other ones over here like copper or iron. Those two are multivalent. So for these here, these ones that are multivalent, you're going to have to do the reverse crisscross rule. For these up here that are just standard metals, those ones you're not going to have to do it because you don't need to write a Roman numeral when you're writing the name. Okay. So Right now, you should pause the video and you should give these a try. Try writing the formula for each of these, and by doing the crisscross rule. And for down here, you're going to write the name. The names are pretty simple for the simple binary ones, and for the multivalent ones, you got to identify which ones those are. Those ones you're going to have to do the reverse crisscross rule in order to figure that out. Okay, I'm going to give you guys an opportunity. Like I said, you can pause, and then I'm going to come back and I'm going to try this, try to take some of these with you. Okay, I'm assuming at this point you have tried them, so I'm gonna run through them fairly quickly here, and you can check your answers. Okay, see where we went wrong if you did go wrong. Okay, and I'm gonna go like I said, I'll go fairly fast. Okay, sodium, which is Na plus, fluorine is 1 minus, so this is just going to be NaF when you do the crisscross. Aluminum 3 plus, nitrogen 3 minus, crisscross and reduce in this case, so this is just going to be ALN because they're both divisible by 3. Potassium is 1 plus, sulfur is 2 minus, crisscross and you're going to get K2S. Lithium is 1 plus, iodine is 1 minus, this is just LiI. Calcium is 2 plus, bromine is 1 minus, so you're going to get CaBr2. Beryllium is 2 plus, oxygen is 2 minus, so this is a case where they're both divisible by 2, so you can reduce, this just becomes BeO. Okay, here we go. Now we've got a multivalent one. So we know that when we write the ion, it's going to be nickel 2 plus, and it's going to be chlorine 1 minus. So when we crisscross that down, it's going to be NiCl2. Magnesium nitride, we got magnesium, which is 2 plus, and nitrogen, which is 3 minus. This is going to be Mg3N2. Aluminum 3 plus, sulfur 2 minus, Al2S3. Okay, another multivalent one. So this is copper 1 plus, and then bromine, which is 1 minus. This is CuBr. Tin 2 is SN2 plus. Iodine is 1 minus. So this is going to be SNI2. Iron 3 is Fe3 plus. Chlorine is 1 minus. This is going to be FeCl3. Calcium is 2 plus. Phosphorus is, oh, why does this one always slip my mind? Phosphorus is in the same group as, as nitrogen, 3 minus. 3 minus, so this is going to be Ca3P2. Lead 2, oxygen 2 minus. This is going to be another one where you can reduce. So this, this just becomes PbO. Does he reduce them? Lead 4 is not 2, Pb4 plus, and fluorine is 1 minus. So this is going to become PbF4. Tin 4, bromine 1 minus. This is going to become SnBr4. Copper 2 plus, sulfur 2 minus. Wait, sulfur 2 minus? Yeah, sulfur 2 minus. This is a crisscross and reduce because they both are divisible by 2. So this is just CuS. Iron 2 plus and oxygen 2 minus. This is another example. Oxygen 2 minus is another example of them both being divisible by 2, so you can crisscross and reduce. This just becomes FeO. And the last one, calcium nitride, is Ca2 plus and N3 minus. You crisscross and you get Ca3N2. Okay, so if you've looked those over and you're good to go, then awesome. Let's let's try these real quick. Most of these look like they are just regular metals. So I'm just going to go through, actually it might be easier here if I just go through and identify which ones are just regular metals that aren't multivalent and which ones are multivalent. So I'm going to highlight all the ones that are multivalent. So lithium, not multivalent. Aluminum, no. Magnesium, no. Calcium, no. Potassium, no. Beryllium, no. Sodium, no. Aluminum, no. So copper is, and iron is. So those two are multivalent. We're going to have to do an extra step. Lead is, tin is. Sodium, no. Magnesium, no. Nickel is, copper is, lead is, iron, calcium, no, and potassium, no. Okay, so those ones where I've highlighted there, those ones are the multivalent metals. That's the first thing that you've got to check. So I just did that by going and having a look on the periodic table here to see, are they multivalent? So you have to look it up. Once you're comfortable, once you've used it a bunch, you'll get a feel for it and you'll just know which ones are multivalent. So that makes the ones that aren't multivalent really easy because you can just name these. This is lithium oxide. This is aluminum chloride. This is magnesium sulfide. I probably don't need to go through these. So for these regular ionic compounds that don't have a multivalent metal, no big deal. You just write down the names of the ions. So the tough ones here are these ones. So copper chloride. Okay, let's do the reverse crisscross on this. We're going to bring a 1 up here, and we're going to bring this 2 up here. So now we have a charge for copper of 2 plus and a charge for chlorine of 1 minus. And you need to look up, is this correct for the nonmetal? So you go and look it up, and yep, -1 is correct, which means this is also correct. So this is going to be copper 2 chloride. Okay, what about this one? Let's do the reverse crisscross. So again, we know it's multivalent, so we're going to do the reverse crisscross. 3 plus, 1 minus. All right. So then we need to check, is this correct? Yes, it is in this case. Bromine has a charge of -1, which means that the iron charge is correct, and this becomes iron, what is it? Iron 3 bromide. All right. PBS. Bring that 1 up here, bring the 1 up here. So is this correct for sulfur? No. So sulfur is supposed to have a charge of, where is it here? A charge of -2. I wish I would keep my place. Charge of -2. So I need to multiply that by 2 in order to get the correct charge. So I'm going to multiply this by 2. I'm going to multiply this by 2. And we're going to end up with a total charge here of 2 for the lead, which means it's lead 2. Whoops, not kid. Lead, no caps. Lead 2 sulfide. Okay, reverse crisscross. We've got a charge of 1 minus 2 plus. Is this correct for oxygen? No. We need to multiply it by 2. Which means we also need to multiply this one by 2. So this is going to be tin 4 oxide. Okay, next. Bring up the reverse crisscross. 1 plus 1 minus. Is this correct? So, no, that is not correct. Oxygen is supposed to be a 2. So we have to multiply it by 2, which means we multiply the other one by 2. So this is nickel 2 oxide. Am I almost done here? Yeah, okay, 3 more. By the way, at any point here, if you're totally comfortable, you're good to proceed to the exit quiz. Okay, so if you're at this point, you're just like, all right, I get this. Just go and do the exit quiz. You don't need to keep going with me. So I'm going to keep going for the people that are like, I need a couple more. All right. So we got 1 minus, 1 plus. Is that correct for iodine? Yes, it is. So this is copper 1 iodide. Lead, chlorine 4 plus. Oh, that's 4 plus. 1 minus. Is this correct? Yep, that's correct, which means this is correct as well. So this is lead 4 chloride. Last one, home stretch. 1, this is 1 plus, 1 minus. Okay, is that the correct charge for phosphorus? No, it isn't. Phosphorus is supposed to be 3 minus, which means we have to multiply this by 3, which means we have to multiply this by 3, which means we're going to end up with iron 3 phosphide. Okay, and there you have it, guys. That is how to name ionic compounds that have a multivalent metal and how to write the formula for compounds that have a multivalent metal. Next time, we're going to throw another wrench in the gear, and we're going to start talking about what happens when ions themselves, like the component parts of these ionic compounds, actually have more than one atom in them. So those are called polyatomic ions. We're going to talk about that next time. But for now, you've learned 2 new skills. Try the exit quiz, see how you do. And again, if you're looking at this and you're like, come to the question period 1 p.m. on Friday, and we'll chat. I will see you next time.